Hi everyone! Today I'll be testing an improvised arc furnace setup. Have you ever wanted to melt something, but your regular gas torch just didn't cut it? Either taking way too much time or simply not reaching a sufficient temperature. Cue the humble stick welder, more formally known as manual metal arc welding machine. Everyone has one, and it can easily produce temperatures comparable to the surface of the sun. Using graphite electrodes gets you temperatures close to the sublimation temperature of graphite, while the arc itself can easily get up to 20,000 degrees Kelvin. My setup consists of a 150 amp 26 volt stick welder, graphite electrodes. I use electric gouging rods, but I remove the copper coating from them. It is important because otherwise it will vaporize, and that's not good. Graphite crucibles, and lastly a foamed concrete block. I constructed a simple furnace and got to work. A disclaimer: just like ordinary welding, the process deals with high temperatures, strong UV light, and an electric shock risk. Proper safety equipment must be used. Furthermore, the process produces toxic fumes and gases. All welding produces ozone and nitrous oxides, while melting the wrong kinds of metal will get you metal fumes. For the first test, I weighed out 5 grams of my lye and sugar reduced silver. The metal should be pure in the sense that there is no other metal present, but it does have an unknown amount of organic residue that should burn off. I packed it into a crucible and topped it with borax, soda and silica based flux. The same flux I'm using when I melt things with MAP gas torch. I apply the personal protection equipment, turned on the welder and struck an arc. I could see the silver contract and shrink as the powder was sintered together, and the impurities were either vaporized or dissolved in the flux. Shortly after the silver melted, the flux appeared to start boiling. I do not know what exactly happened, but I stopped heating and poured the silver out of the crucible. The entire melt took 4 minutes. The arc was not on the entire time. I botched the pour and produced some Bigfoot level freehand footage at the same time. I got 3.9 grams of very nice looking silver. I do not know if the weight loss is mostly due to the removal of the impurities or the vaporization of silver. but both no doubt played their part. I crushed the green slag and was positively surprised to find there were no silver beads in it. When I melt silver with a map gas torch, I never get this good of a separation. Now let's move to something a map gas torch won't melt. Palladium melts at 1828 Kelvin, which is high but still nothing compared to the max possible temperature of the arc. I weighed out 1 gram of cemented palladium of unknown purity. I transferred it into a crucible and covered it with flux. After heating it for a minute or two, I ran into the same thing as with silver. The flux began to boil at a temperature lower than the melting point of palladium. The palladium itself did not melt, but it did sinter together, so I removed it from the crucible, placed it on a found brick, and directly heated it with the arc. It melted in a few seconds. I failed to record this particular bit because, apparently, thick leather gloves and touchscreens don't mix. Anyways, I got 0.663 grams of what looks like palladium. Again, a loss of a third of the mass isn't ideal, especially when I have no clue if my palladium is just very dirty and the loss is due to the impurities dissolved into the flux, or if I just vaporized 20 euros of metal. Wouldn't be the first time, but probably both effects are in play. The system I have works for silver. With palladium, I ran into a problem that forced me to melt it directly in the arc. I believe that, with a high temperature flux, melting palladium in a crucible will have lower losses. I will do some more research and experiments, and I will post an update when I get a working system that can be used for melting platinum group metals. Lastly, let's make some rubies. Making amorphous rubies is trivial. You just need something that can melt aluminium oxide doped with a bit of chromium. I know everyone and their grandma already saw and done that, but it is a nice demo, so I had to do it. Chromium ions give rubies their signature color and a strong fluorescence under UV light. They are nice, but also not worth anything. Growing actual ruby crystals takes a lot more effort. I don't have the equipment to do something like that yet, but I really do want to do it sometimes in the future. Like and subscribe to support my many projects. See you next week.